domain and range for quadratic functions. Let's talk about that. Okay, so for this one, we're being asked to find the domain, not the range, just the domain. And so when we're looking for our domain, we're considering x numbers, the x numbers that are in the table. That's what our domain is. Okay, so when you're thinking about this one, let's think about all the x numbers that we would find on our graph right here. Okay, let's start with the obvious one. -1. Is -1 on the graph? The answer is yes, because I can see the point right here. Okay, so I put -1 as one of my x values, and then I test 0. Is 0 on my graph? The answer is yes, it's right there. Okay, so that means 0 is on my graph. What about +1? Is +1 on the graph? Yes, it's right there. Okay, that's cool. So I can put +1 on in my table. So that's part of the domain. But now I get to the weird stuff. This -2 right here. Is -2 on the graph? And we go up the -2. I'm sorry, not -2. We go up the +2 line all the way up, and we see that this graph doesn't hit it yet. But because of this arrow, we know that this line is going to continue going up and to the right. And so, yes, it will eventually hit a point that has an x value of -2. And so will all of these other x values. Because this line is continuing to go up and to the right, it's going to hit all these x values. But that's not it, Stews. All the values that are in between these x values, the decimals, it'll also hit all those decimals. But that's not it, Stews. What about this side of the graph? That's right. All of these x values will also be hit. The numbers and the decimal numbers. So instead of listing out every single number, including the decimals, which I didn't even write, there has to be a better way of writing this. And there is. All we have to do is write all real numbers. That's our answer. Boom. Now, if you want to get really fancy, you're my students, so I got to make you guys fancy. You could write this in set notation, which is what this notation is right here. It's called set builder notation. You would write the squiggly line, and you would say x, such that x is all the numbers in the set of real numbers. That means such that. That means all numbers in. And that means the set of all real numbers. Okay. Now, if you want to be fancy, you can write it like that. But if you just want to write all real numbers, that's sufficient. Now, when you guys are thinking about domain, don't forget, those are the input numbers. Those are the x values. Those are the numbers that you would plug into a function. And when you're thinking about it like that, you're like, well, what number can I not plug in? Right, there's none. You can plug in all the numbers, all the real numbers. So that's why the domain for quadratic functions are always all real numbers. Okay, finally we get to the range. This one has us find the range. Now for the range, you're concerned about all the y values. All the y values. Now we should probably erase this because none of these y values are on this graph. The top number, the highest number is right there, and that is a 5. That is the highest y value that is on this graph. And as I go down, I see that the 4 is on the graph. I see that the 3 is on the graph. I see that the 2 is on the graph, so on and so forth, all the way down the graph. In fact, this gets kind of old. So I'm just going to put an arrow right here and say all of these y numbers are on the graph. Okay, but what about the decimals? Like this decimal right here. This decimal is on the graph. That's a number that's between 5 and 4. What number is between 5 and 4? Well, actually, there's a lot of numbers between 5 and 4. I'm just going to put 4.5, but there's 4.1, 4.2, 4. You get the point, okay? And even these decimals down here, look, there's a decimal right there. What decimal is that? That's between -1 and -2. So what number could go between those two? And the answer is 1.5, or -1.5. Or we can say -1.1, -1.2, -1.3, you get the point, okay? So we have to include all the decimals and all the whole numbers. There must be an easier way to do this, and there is. We're just going to write set builder notation, so it kind of looks like this stuff. So we say y, the range is y, such that y is less than or equal to 5. And we're saying less than or equal to 5 because the graph opens downward. Just as a reminder, when you read this symbol right here, you say is less than or equal to. So this would be our answer right here. We know it's clearly not this one because it has the wrong sign. It says y is greater than instead of y is less than 5. And then this one has two numbers. So weird. Y are 5 and 7. Okay, which is like for certain special functions, this could be true. But I think what they're trying to do is they're trying to fool you because 5 and 7 is where the function intersects the x-axis. But the range is not x numbers. So here, just as a reminder, when you read these signs from left to right, like this one right here, you would read this one as greater than or equal to, and you would read this sign as less than or equal to. And I remember this by thinking about the two words, greater than and less than. Greater, I say greater because as I'm coming towards this sign, I hit the side that's greater before I hit the side that's smaller. And that's why when I see the smaller side first, as I go this way, I think less than. Lastly, just a quick reminder, the range is the output. Those are the y values. Don't forget that.